Welcome back to the second section of chapter 4. So we've seen degrees and radians. Now we're going to get into triangles, specifically right triangles with those acute angles. And we're going to be looking at these 6 different trig functions. Yes, I said 6 different trig functions, not just the 3 that you were looking at in geometry, but there are 3 more. And those 3 are actually very similar to the first 3, so they're really not that big of a deal, but we do have a total of 6. So let's look at our learning targets. We're going to find trigonometric functions of any angle given side lengths of a right triangle. We're going to give the values of one trigonometric function, or given the values of one, find the remaining functions. That's one trig value to find them all. It's a very Lord of the Rings feel to that one. Evaluate trigonometric functions without a calculator. Find an exact value of a trigonometric function by using a calculator, and then approximate trigonometric functions using a calculator. Using a calculator to find trig functions is, in theory, pretty easy. You just type it in. We're going to focus more on what can go wrong when you're trying to use a calculator, because that's what gets people. So, right triangle trigonometry. We're going to be looking at acute angles. So for this, we always get angles, and we're going to put them in standard position, generally speaking. Standard position takes the angle and it puts it at the origin in the coordinate plane, which allows us to use points and distances and stuff like that. And then the angle is measured from that positive x-axis, and it's measured going up from there. So that's what's called standard position. Now, when we were looking at triangles and shapes in geometry, we're looking at similar figures. Similar figures are figures that have the same shape but different sizes. So the angles are the same, but the side lengths are different. What that means with trig is that when we take ratios of the sides, we're always going to get the same number as long as that angle is the same. And that's where those trig values come in. So when we have a right angle, a right triangle, we have to focus on one angle, which is not the right angle. We need to choose one of the 2 acute angles to look at. From there, we have an opposite side that is directly across from it. We have an adjacent side that's adjacent to it, and we have the hypotenuse, which is adjacent to it and also opposite the 90-degree angle. So, what are those trig functions? We have sine, cosine, and tangent. I know when I learned those, I learned an acronym with it, which, generally speaking, I'm not a huge fan of like those learning mnemonics, things where it's like, hey, if you can remember this jingle, then you can remember this little thing. I always figure, well, just remember the little thing. You don't have to remember the jingle. That sounds like a lot more work. This one's a lot simpler. Like, it's so useful, I still look at it. But this is SOHCAHTOA. And what this says is that sine of the angle equals the opposite side over the hypotenuse. Cosine of the angle equals the adjacent side over the hypotenuse. And tangent of the angle equals the opposite side over the adjacent side. So if we have sides here, which we're going to have in just a second, if we have sides, we can find all the different ones. Actually, let's throw an example up here. So let's get a right triangle, and let's say this is a 3, 4, 5 right triangle. Here's our theta. So what we have here, Sine of theta is the opposite over the hypotenuse. That's 4/5. Cosine of theta is the adjacent over the hypotenuse. That's 3/5. And tangent of theta equals the opposite of the adjacent, which is 4/3. So those are the three that you've already seen. Now what about the other three? The other three are going to be cosecant, secant, and cotangent. So these are actually just the reciprocals of sine, cosine, tangent. Cosecant is the reciprocal of sine. A lot of people want to go to cosine for that. No, it's the reciprocal of sine. So it's the hypotenuse over the opposite. So in our example here, the cosecant, instead of 4/5, it's 5/4. The secant is the reciprocal of cosine. It's the hypotenuse over the adjacent. So instead of 3/5, it's 5/3. And the cotangent is the reciprocal of tangent. So it's the adjacent over the opposite, which is 3/4. So notice that the fractions just get turned upside down. That's why I say like those three, they're new, but they're really not that different. It's using the same things, it's just upside down. Why do we have 6? Because with these three sides, these are the only 6 possible ratios with 3 sides. So that's why we have all of them. So finding specific ones, we can find the trig values of 45 degrees, and this is something that you will need to know very shortly. There are some special angles, which we're going to see most of them actually today, where we get the exact values of the trig functions, and we use these angles a lot, and so it's something you're just going to need to know. It's probably going to take a little bit of memorization. A lot of that comes just with practice and stuff too, but it is the way it is, and it will be useful later on. So, trig functions of 45 degrees. We know it's a right triangle. So one of the angles is 90, which means that the other angle also has to be 45. And so it is an isosceles right triangle, which it doesn't matter what the side length is, it just has to be the same. And then we can find the hypotenuse. So we can make the side length 1. We can go 1 squared plus 1 squared equals 2, and then square root that to get the hypotenuse is root 2. So we can find the values of this. So we take a 45, so sine of 45 degrees is opposite over hypotenuse. That's 1 over root 2. Now we can actually leave this like this. I know that in the past, it's always been like, we have to rationalize the denominator, multiply by root 2 over root 2 to get root 2 over 2. It really doesn't make that much of a difference, honestly. At this point, we can go either way. We're going to be using calculators. It's the same. The cosine of 45 degrees is going to be the adjacent over the hypotenuse, which is also 1 over root 2, which is root 2 over 2. The tangent of 45 degrees is the opposite over the adjacent, so 1 over 1, which is 1. And then we can find the other three as well. The cosecant of 45 degrees is going to be the hypotenuse over the opposite, or we already have sine, we can just flip it upside down. So instead of 1 over root 2, it's root 2 over 1, which is root 2. The secant of 45 degrees is also root 2, being that the sine cosine were the same. The cosecant and secant will also be the same. And the cotangent of 45 degrees equals, well, instead of 1 over 1, it's 1 over 1, which is still 1. So those are the trig functions of 45 degrees. And anytime it's 45 degrees, we're going to get exactly those values. So it doesn't matter what the size of the triangle it is, as long as the angle is 45 degrees, those ratios will be the same. Um, Another one is a 30-degree triangle. Now, a 30-degree triangle is a little bit tougher to do than a 45, but to get a 30-degree, so this is going to be a 30, 60, 90 triangle. To get one, we could actually start with an equilateral triangle, which is 60, 60, 60, and then bisect one of the angles, which bisects that opposite side. So we get, in this case, start out with side 2, so when we bisect, we get the side of 1, and then we can go 2 squared plus 1 squared, or 2 is the hypotenuse, so we can go 2 squared minus 1 squared equals 3, square root, to get root 3 for that side. So our trig values, now we're looking at 30 degrees, so this is the opposite, this is the hypotenuse, and this is the adjacent. The hypotenuse and the adjacent switched on us here. The sine of 30 is the opposite over hypotenuse, so that's 1 over 2. The cosine of 30 equals adjacent over hypotenuse, so that's root 3 over 2. The tangent of 30 is opposite over adjacent, so 1 over root 3, which you could make root 3 over 3. I know that sometimes that gets a little bit ingrained and it doesn't feel right if you don't do that. Cosecant of 30, we have the inverse of sine, the reciprocal of sine, so instead of 1 over 2, it's 2 over 1. The secant of 30, instead of root 3 over 2, it's 2 over root 3, which you could multiply by root 3 over root 3 to get 2 root 3 over 3. And the cotangent of 30, instead of 1 over root 3, it's root 3 over 1, and that's what we get. So that's of 30 degrees. What if we wanted the trig functions of 60 degrees? Well, if we look at this angle now, the hypotenuse is the same, the opposite and the adjacent switch. So if we want 60 degrees, we would switch the sine, the cosine, we would switch the cosecant to the secant, and we would switch the tangent and the cotangent. So of 60, like just looking at, so let's go sine 60, cosine 60, tangent 60, cosecant 60, secant 60, and cotangent 60. So with these, we switch like the opposite and the adjacent switch, which means the sine and cosine switch. So instead of 1/2 root 3 over 2, we get 1/2 as the cosine, and root 3 over 2 is the sine. Same thing with the cosecant and secant. We get 2, and we get 2 root 3 over 3. And then tangent was opposite over adjacent, and so if we need to switch those, we get adjacent over opposite, and so tangent and cotangent switch. So tangent was 1 over root 3, so that'll be the cotangent, which was root 3 over 3. And the tangent is now what the cotangent was, which is just root 3. And you can look at the triangle and you can see how the opposite and the adjacent work. So you could have figured that out just from that. But it also, that's what happens with the features for the trig functions from the other angle. Everything switches with its sine and cosine switch, secant and cosecant switch, tangent and cotangent switch. So that's why they're paired like that. One of the reasons. There's a few more. So how do we use one trig ratio to find all the trig ratios? Well, if we know that we have theta and it's an acute angle, so we'll get to non-acute angles here pretty quick. Not today though. So sine of theta equals 5 over 6. Find the other 5 trig functions. So we're going to draw a picture. We know we have an angle that we're working at. It's a right triangle. And we know sine is 5 over 6. That gives us the opposite and the hypotenuse. So we could draw a picture right here. We have the opposite and the hypotenuse. We can find that third side. So we know that 6 squared equals 5 squared plus x squared. 6 squared is 36, 5 squared is 25, plus x squared. Subtract, 11 equals x squared, square root, x equals root 11. Notice this was just positive. We don't need negative because it's a positive value. So we can find the trig function. So sine of theta, we know that one's 5 over 6. Cosine, tangent, cosecant, secant, and cotangent. So we know that sine is 5 over 6, which means cosine is 6 over 5. Cosecant is the adjacent over hypotenuse, so that's root 11 over 6, which means secant is 6 over root 11, which you could make 6 root 11 over 11. Tangent, opposite over adjacent, so 5 over root 11, which would be 5 root 11 over 11. And cotangent is the reciprocal of 5 over root 11, which is root 11 over 5. So if we know just one trig function, we can use that, label the sides, and then find the third side, and you have every other trig function that you could want for that triangle. Evaluating with a calculator. So again, with a calculator, you type it in, you hit enter. That part's pretty easy. The trig buttons, sine, cosine, tangent, are usually right on the calculator itself, so that they're easy to find. And you just type it in. Sometimes you have to type in the trig function and then enter the number. Sometimes you have a number entered and then you type in the trig function. Those are more on the older calculators. The graphing ones, you would do the trig function. It would pop up with parentheses, and you have to put in the value you're looking for. So what could go wrong? First one, being in the wrong mode. We'll be going from degrees and radians. I know the graphing calculators are default set to radians because that's what's used more. So if you're doing something with degrees, you have to change that. Sometimes there's a second button, like if you're using a scientific calculator. Sometimes there's a second button to change it from degrees to radians. Degrees is usually abbreviated DEG, where radians is RAD. You might have a GRA as well. That's a gradient. That's something completely different. But you need to make sure it's in the correct mode. And this is huge because if it's not, you're still going to get an answer. So if we do, like, say, the sine of 10, and so that would be sine of 10 degrees, but it might give us negative 0.544, blah, blah, blah. And so that's probably the first negative sine value you've seen. But also, like, the sine of 10 should be a positive value. This one's a negative value. And what happened here is that it was in radian modes instead of degree modes. So it was looking at 10 radians, which is all the way around the circle, and then back into the third quadrant. And so we get that. So make sure it's in the right mode. Sometimes it's in the mode menu, sometimes it's in the second. For the TIs that a lot of you have, it's in the mode menu. Using the inverse trig keys for cotangent, cosecant, and secant, there are no keys for those other three. You have to find them because they're just reciprocals. And so doing something like this, the inverse tangent, that's like the second tangent button, gives you tangent to the -1. That inverse is not the same as a reciprocal. This would be saying the inverse tangent of 30. So we had a ratio of 30, and that's going to give us an 88.090, etc., degree angle. So we do this, we go from the ratio back to the angle. We'll be working on this in a couple days. What we could do, instead of using the second trig keys, you could type everything in and then use the x to the -1 button. That's the reciprocal button. That will actually flip it upside down. So you can use it that way. Use the -1 button. I generally don't. I don't trust those. I do things by hand, then maybe I'll get a value and do to the -1 or go 1 divided by whatever I had. But what's important here is that you do not use those for your inverse trig. Using function shorthand, the calculator doesn't recognize. So when we have things like sine cubed, we write it like that. We put that cube there. And what that means is this is sine of x cubed. A lot of times, the calculators don't like that. And so you'd have to do it that way. You get sine x, it's a number, and then you cube it. It means the same thing. But again, the calculators don't usually like that exponent up there. And then not closing your parentheses. So the top one, we have sine of 30, which is 0.5. And the next one, we have sine of 30 plus 2, which is 0.5299. What happened, because that should be like 2.5, didn't close the parentheses, so we were doing sine of 30, sine of 32. And so keeping track of those, I mean, that just added a lot of extra work that people didn't have to do. Keeping track of those parentheses, you close them. Not a lot of work because you had to go back and do it. I had a thought process with that, but I lost it. Anyway, so the sine of 30 plus 2 got us that because it's just a sine of 32 degrees, when chances are person wanted this. But notice that these two things are different. When I do these, it is like I will do sine of my angle, enter, and then I will add whatever's on the end of that. Or I'd go 2 plus sine of 30, just to make sure that I don't accidentally get something where it's not supposed to be. So, not closing parentheses is the other mistake people make. The big ones, wrong mode. That's huge. And then people doing that, but they don't do that very often. And a lot of times when you do that, you end up with an error. So it's not that big of a deal. Just like this one usually end up with an error as well. Solving a right triangle. When we solve a right triangle, that means we know all three sides and all three angles. So if we have a right triangle with hypotenuse of 8 and includes a 37-degree angle, find the measure of the other two angles and the other two sides. So draw a picture. We have a hypotenuse of 8 and angle is 37 degrees. We need to find the other two angles. Well, one of them is 90, and the other, we can go 90 minus 37 to get 53 degrees. And now we can use trig. We know the sine of 37 degrees is going to equal the opposite over the hypotenuse, a over 8. To find a, we just multiply by 8. So a will equal 8 sine of 37 degrees. The sine of 37 degrees is just a number. Plug it into your calculator, multiply by 8, and we get about 4.81. So A equals about 4.81. Now, is it exactly 4.81? No. Generally speaking, side lengths about 2 decimal places is okay. So we'll leave it there. So that was A. Then we also need B. Well, B, that's cosine, uses that in the hypotenuse. So cosine of 37 degrees equals B over 8, which we can multiply by 8 to get B equals 8 times the cosine of 37 degrees. Plug that into your calculator really quick to get about 6.39. So there's all three sides. We have 4.81, 6.39, and 8. And we have all three angles, 37 degrees, 90 degrees, and 53 degrees. And so that's how we can solve for a right triangle. An application, find the height of something. Now this is a common type of question that people say like, oh, when am I ever going to use this? I have actually used this. I have used it to find the height of trees that I had to cut down to make sure it wasn't going to land on my house. It's a pretty important thing. I should have used it to figure out how tall my Christmas tree was going to be. I did not. That's okay. It fit. So to find the height of a building, let's say that from a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia, the angle of elevation to the top of the building is 65 degrees. See the figure? There's a figure. Find the height h of the building. So to do this, we have, this is our 90. So we're working with the adjacent side and the opposite side. So that's going to give us tangent. Tangent of 65 degrees will equal the opposite side, which is what we're trying to find, over the adjacent side, which is 340 feet. We can multiply to get h equals 340 times tangent of 65 degrees. Plug that into a calculator really quick. Tangent of 65 times 340, we get that it's about 729 feet tall. And we were able to do that without trying to measure the actual height of the building. This is called indirect measurement. And it's, again, a pretty straightforward application. Uses a trig and right triangles. So this is what we're working on for this section. I will see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.